So, how was your day off? I saw lots of good activity in the Discord channel, so hopefully your term project meetings are going well. Let's see that. Alrighty. So, yeah, on Friday, I was actually at it's a Google-related conference. Um, One of the things I haven't really talked about at all is that I can get you all credits to use Google Cloud stuff. Hasn't been an integral part of the course yet, and we'll probably do a little bit of something with it later on. If you feel that you're going to want a web server or some kind of a server environment, let me know early and I can get you set up with some of this stuff. In a lot of my other classes, I've used Google Cloud for like hosting portfolio pages or um, various term project activities. So can get some free stuff through them, totally free for the semester. We're using GitHub a little bit more this semester for you all. But if you're looking at doing something a little bit more in depth, maybe you're going to reach out to a machine learning API or Google Maps or anything like that. You can actually do it for free through Google if you want. Like you can use pre-trained vision models if you want to use a phone camera for anything, or AutoML. It's a kind of like a drag and drop machine learning modeling type of thing. Not trying to like say you have to go out and use it, more that there's another resource that we haven't really talked about yet. If you um, want to go ahead and use it, you don't have to. They also have a whole bunch of little code labs out there too for doing interesting things. Like you can use TensorFlow to make a magic wand with an Arduino, or when I've had my sysadmin students do, they set up a worldwide load balancing network using actual servers in like Asia and Russia and various Americas. So you do some pretty cool stuff in here, and it would be all for free to you, so nothing to worry about there. But if you, obviously that's a little bit ahead of ourselves right now, but if you think you know what you want to do and you want something like that, let me know early and I'll sling some credits your way. Basically, the way it works is that you would get, I think, $50 coupons for their cloud stuff. And if you remember to turn it off, that's pretty much good for the whole semester. But if you run out, I can get you more. It's like basically free for you all, which is pretty cool. All right. So does anybody have any questions on how the meeting minutes and everything like that went? So kind of got your first look at hopefully what a meeting should be. And I gave you some pre-seeded questions to put in your discussion points and a little bit of extra work than you normally would, but I kind of wanted to get everybody going earlier rather than later. So did that go okay for you all? Hopefully. Yeah, pretty good overall. That's good. Checking my stream settings over here because my internet was really bad this morning. I don't know what was going on. That's good. Yeah, and again, if you have questions, please feel free to keep them coming. I've had some people drop by the office hours, which is good. Again, if you're not aware, it's in the Blackboard Collaborate link that is in the Blackboard page. I will look through your submissions. So again, every Sunday night, all future ones will go into GitHub. And since let's see, so we have basically your ones for next week, we could just roll into your term project submission later on. I'll let you all know about that. I'll read through your submissions for the meeting minutes and I'll give you feedback on your proposal or your elevator pitch, I suppose, as well. We don't have code to discuss. Well, yeah, so that's kind of the thing too. It's not always about coding, right? And that's kind of what we're learning in this class is that a project is not strictly coding, it's getting all the pieces in place, right? So what are the high level features you're looking to do? What are the low level features? Coding, you'll get there, don't worry. But I'll give you feedback basically, so I'll help you scope things out. So if you have like a team of 5 and you're proposing a single form basic application, I'll probably ask you for a little bit more. And if you're going super crazy with features, it would take a 100-person team an entire year to build, and there's 3 of you. I'll give you some maybe scoping help as well. But yeah, kind of the goal was to start feeling out how meetings would go for your teams, honestly. Ease you into it a bit. But as long as that's going well for you, that's what counts for me. And yeah, so I have another conference in October, so we'll probably do something similar. Probably, I think it's the first or second week in October. Gotta figure that out. Um, where I'd have to be gone for the day, kind of something like that. I will let you know, and you will have stuff to do during that time, so no worries from your end. All right, so today we're going to talk about configuration management. And I'm trying to start saying config just to make life a little bit easier. And it's going to sound really funny, but we're going to be talking about this mostly this week. So everything that you've been doing so far, and I've been kind of forcing you to get used to Git and GitHub, probably a little bit earlier than most classes would have you get used to it. It's really hard not to make Git puns every time I say Git, 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 Git. But it's a very important piece of the software development puzzle, honestly. GitHub is one technology, and Git is one technology. GitHub is just the pretty front end for it. Um, we're going to kind of talk about the classical side of configuration management today. So if you have any knowledge of revision control or source code control, these terms all basically mean a similar thing. If you know something like Subversion or any of the paid schemes that are out there, that's kind of analogous to what we're talking about today. We'll talk about Git a little bit more on Wednesday. It's got a slightly different philosophy behind it, so we'll kind of cover what that is. But we're going to go through everything dealing with configuration management. So first thing we're going to do, we're going to start off with a little Slido survey, and I need to reset this because you don't need to see the morning's answers. Let's keep it active. And I need to do this. So this is what Slido looks like. If any of you have any desire to bake any of this into your slides at any point in time, I want to reset this. And now I want to present again. Get my secret notes. And there. All right. Try this again. So how many of you have ever used source code control before, or revision control, or anything like that? I'll make sure this still works. And the kitties this morning got a chuckle out of the ID for the slide, for the quiz. Auto-generated, by the way. What source control? Hey, got some of those answers this morning too. So if you started the lab that's due at the end of the month, 29th, I guess, not the 30th, but you will have used it. Okay, so we are talking about managing and tracking everything related to a project. All right, so yes, no, what source control? Hey, more answers than not from before. That's kind of funny. Every time we've talked about Git, you've been using source control. So that's what that is, right? You are managing versions of your code. You're also managing versions of your artifacts, your documents, your executables, even if you check those, and anything related to your project can be put under revision control or source control. Okay, so that's what that is. So if you haven't done any of the homework yet, your answer is probably no. If you started it, you should have had an easy yes here, which is fine. Everybody's changing as we go. Or maybe people are polling here still. That's funny. Kind of fun watching the little graphs change on my end. And I would have loved to have had this kind of slide interactivity when I was working in industry. This would have made presentations so much more fun. Alrighty. So the interesting point for you all, and what takes this from just boring old source code to project control, is that you can put whatever you want under revision, basically. So the whole point of this notion of source control or revision control, I'm just going to keep throwing these terms at you so you get used to them, is that you are tracking everything in your projects. Right, so source code, again, I keep mentioning this. This is just one piece of the puzzle. There's also all of the documentation. Right, there's your project proposals, which you're checking in at the end of the month. We'll probably revise those as we go, meaning you're going to make commits as we go and they're being revised, right? You can also put your requirements under revision control, all of your artifacts under revision control, everything can be in your source code repository. So basically you can use it for just more than source code. Let me take a quick little divergence here. My sad looking box man there. So this is our GitHub repo for class, right? Hopefully you all have seen this. This is what you have to fork for your project teams. So this is our source control here. This is our revision control for our term projects. You just have one folder for source. You also have folders for your artifacts. These are going to be your UML diagrams, right? These are going to be your class diagrams. Documents. Put your proposal templates in here. Put your requirements docs in here. Put your final report in here. This is all going to be under revision control. Meeting minutes. We'll have that, right? Website. You're going to create a little simple website for your projects. HTML, maybe, maybe not source code, depends on what your philosophical stance is on that one, but that will be in here as well. Right? Style sheets. Everything can be under source control. And the thing that makes this interesting from a project management perspective, this is kind of more specific to GitHub, this thing I'm going to show you now, but you would have this in any good configuration management tool. So you click this little projects link. We can start doing things like assigning tasks. We can put to-do items. We can put in progress items. What's done, what's not done. Think of these like if you've ever used something like Trello or any of those card-based systems, like a Jira, if you've ever done help desk support. You have kind of a similar notion here. And we'll get into what this means for some of these other revision control systems as well. But it's all part of the puzzle here. So this very kind of blurry picture that I've got for you here, taken from Wikipedia. I've got the reference in my slide notes, of course. Make sure you put your links all somewhere. This is from the DoD. And the intent of this figure is not to have you memorize every single item here. Obviously, this is kind of a lot going on. But this is the configuration management side of software. Kind of looks waterfall-y, right? So we have some boxes that we're kind of going from one to the other. Right, we also have all of these support activities going on for each of these. So management and planning, we have that kind of in our software development lifecycle, right? So that's figuring out a project. But this also includes here planning. What resources do you need? How much time is each task going to take? Right? What are the relationships between your employees? You have things like logistics and requirements and contracts and change requests and all of these kind of high-level bullets that are strewn throughout this figure. They're all going to go into your various activities that you have when you're developing software. And here again, this is a configuration management view of things, so you're going to be looking at what kind of configuration tools you need, control aspects, maybe accounting aspects, and this is not necessarily strictly budgetary. It could be accounting for, who's accountable for what aspect of which project, basically. Auditing, verification, that's our maintenance and deployment tasks later on. All of these different pieces are going to fit in, and all of these different pieces will be supported by some kind of a configuration management system. All right, so again, very busy figure. Let's look at it a little bit simpler. So this spiral um, you know, our software development flow that we have here, starting with planning, going all the way through to maintenance. You've seen this before, and I've probably beaten this horse so hard that it's well beaten, I guess. But it's supported by some kind of a configuration management tool. So there has got to be something linking all of these pieces together. And before we didn't have that. We talked about, how the arrows between boxes link up and how there's weights behind all of them. Well, the config management's where that weight is kind of handled. And why do we care about this? It's a really good question, right? So why do we have to go through all the rigmarole of all of this kind of thing? Keyword's going to be consistency. So your projects should be consistent, right? So you're following your process correctly. That's going to be defined by your config management tool. So what are the milestones you have to go to move from phase 1 to phase 2 of the project, right? Which check marks in your tool do you have to click to make your current step or your current phase or gate or whatever you want to call it to make everything green so you can move forward to the next part of your project, right? How do we get from planning to system development to implementation to verification? Well, all of these phases in between are going to be spec'd out by your configuration management system. And this is going to give us consistency. That's the idea at a high level. All right, and again, if you all have questions on this, please feel free to dump them in the chat. I'll definitely be watching that. But let's start with the development side of things. So you're a developer, you're a project manager, you are somebody part of the software development team, and we're all working on this product or this feature, right? Obviously, it's going to involve coding. It's going to involve all of the headaches that we've talked about already in terms of all of the artifacts and whatever process we're following. When we talk about configuration management, we're going to be considering working on files. So we're going to get files. We're going to get sets of files. And what this means is that I'm going to reach out to a repository and pull down files. These could be code, documents, anything that's going to be under control, right? Or under revision control. So we can get files. We also can lock files and unlock files. Those of you who have done an operating systems class or maybe use some common sense, hopefully. Why do we have to lock files when we're working on them? Let's say you're working on a team of like 50 people and you need to update something. Why do we have to lock it? Question to you all. He asked a question. So files are on a need-to-know edit basis, i.e. so people don't screw up. I like that one. How would you tag files? Tagging we'll talk about in a few minutes. So I like your answer. Excuse me. When we talk about locking files, let's think of it this way. What happens when you try to access the same file as somebody else at the same time and try to edit it? And I'm not talking about in terms of like a nice Google Docs format or something like that where it's built to work together, but where it's built for only one person to have at any given time. That's what we call a race condition, right? We don't know what's going to happen. If a system is set up such that a file doesn't have any protection around it, and you and another developer are trying to check something in at the same time, it's possible that the revision control system is not going to know whose is better, whose is in charge. Maybe you get into some kind of a weird conflict. Basically, bad things happen if we don't do this. Need to know / edit basis. I guess I could see that. With getting files and unlocking, you can also assign privileges so that the intern doesn't get access to the production code base, for instance. But yeah, we want to protect ourselves, right? We want to protect our files. You can lock on GitHub. I don't believe you can lock on GitHub. So this is the standard kind of paradigm, I suppose, for development. This is more like the SVN subversion style. GitHub, I don't think we have the notion of locking and unlocking, and I don't want to say that specifically because I can you lock? Sorry, just looking at I Googled it. I just wanted to make sure I didn't misspeak here. I'm pretty sure you can't lock in GitHub. They have a different idea where it's more of a merging and rebasing if you have to do anything like that. So again, this is more the standard side of things. All right, so yeah, and that's the other thing. GitHub or Git is more of a distributed where you'd actually have a repository on your computer. So we'll talk about that on Wednesday, basically. So let's say that we locked a file. We also will then check things in. So when you acquire a lock, it is yours to work on. Okay, so again, file, source code, whatever it is, you can lock it, work on it, then check it in. This is basically like when we do a commit with Git so far, where you commit a version to your repository, you get an identifier, and then that is a check-in. And then you would unlock it so other people can work on it, basically. That's the downside of the standard way. Then we can also tag or baseline them. So tagging, baselining, this is basically creating like a named version. So something kind of human readable that's not just version 1 or version AF12, blah, 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 like GitHub gives you. So this is basically going to be some kind of a release basically. And then we also will branch and merge. So we'll talk about this as well, where you'd have, say, multiple branches for a single file or a single project or something like that. So it just kind of depends on what you want to do. But these key activities are basically what we have going on in configuration management. And there's a little bit more to it as well that we'll talk about here. So far we've been talking about kind of the high level stuff. Here's a nice little figure which is hopefully helpful to give you an idea of what this all looks like. All right. So here we have a file. And again, we don't care what type this is. It can be whatever our system supports. Word documents, Markdown, source code, whatever you want. File A, very blandly named. This is going to have a version. So this v equals x is its current version. So it's like version 0.1. All right. If it is currently locked, we're going to be in this get access loop forever until it is unlocked. All right, so I can't work on something. Let me rephrase. I can work on something, but I can't check it into revision control until somebody unlocks it. I can have a sandbox on my computer where I have a copy of the project. I can do whatever I want on it. And then when I'm ready to check it in, I have to lock everything that I need. If something is locked, it has to be unlocked before my changes go in. And kind of the other downside with this model is that you have to verify that any changes that have been pushed are part of your commit or your check-in, basically. You kind of start to see some of the headaches with the standard model in this regard. But this was used for the longest time, honestly, before Git started getting popular. Anyway, so I have a file and I'm ready to work on it. So I'm going to lock it. I'll make my changes, and then I'll check it in. My version number gets incremented. It's one of the nice things about a more standard model is that version numbers are usually like auto-incremented, where it's a little bit saner and easier to remember what versions are. Like this is version 1.0, 1.1, 1.2, instead of random GUIDs, for instance. So then when we're done, we'll unlock the file. Anybody else can pull it down and work on it now, who has privileges and correct access rights. I should mention too, at any stage in this process, even if something's locked, you can pull down a read-only copy as well. So like if I want to get this project that this file is a part of, even though it's locked, I can still get a copy of it and work on it locally. Just when user Eric, for instance, is done, I would merge his changes into, the current file or something like that. This view is for one file. This can be done on sets of files too. So I can check out a whole project and lock it. Usually if you're using this kind of system, it's a little better and nicer to your teammates if you only lock the file you're working on, because if you lock 500 files at once, it's usually bad. So we have that. But that's kind of the standard source control, file control, revision control step. What takes this to the next level, making it more of a configuration management thing, is adding tasks and adding assignments and a little bit of traceability between your project artifacts. Okay, so exact same figure here. And I'm gonna go to the next slide just to bump the size up a little bit because it's the same figure, just the title changed a little bit and it's a little bit bigger here. Let's say that I'm working on a project and I have something to do, right? Good, good example. I have something to do. Um, I need to add I used a login system this morning. I have to add a artificial intelligence controller for an enemy in a game. All right, that's my goal. So I'm going to add in this new module, which has a very intelligent neural network for its brain or something like that. Going off the rails here. Caffeine's kicking in. Perfect. So file A is my enemy controller. All right, I lock it. I start adding my changes in there. Right, I've coded up this beautiful artificial brain so that it's a super intelligent enemy. Okay, it's part of my super awesome, amazing 2D game. Okay, so I've locked it, made my changes, and now I'm ready to check it back in. What makes this software engineering-y is that I'm just not going to check things in willy-nilly. I'm going to have a reason for doing it. So I'm going to have to file an issue or have a change request or some kind of change authorization where I'm going to connect my check-in to a task. All right, so I might have a card or a requirement or something somewhere in this config management system that is a line that says enemies must have artificial intelligence, right? Or system must have a user login, right? So I'm going to have all these requirements written down, part of this system somewhere, and I'm going to link this change to that requirement. So we're going to have this notion of traceability between all of our pieces, right? So that's kind of where hopefully you can start to see where all of these pieces that we're talking about all link together, and it's underpinned by this config management system, right? So I might have just a general task where it's bug fixes or, something general where I can do little things. But if I'm going to be devoting time to a feature or a piece of the product, I'm going to have a very specific thing to check it in under. And so far, those of you that have been playing with the GitHub homework and all of that, you haven't seen any of this, right? Because it doesn't exist for you. But if you start developing a project with Git or GitHub, you'd do something called a pull request, right? Where I might have a reason to change something, and here is the particular issue that I'm fixing or feature that I'm adding. I've got a specific, again, reason for adding this code or making this change. It's not just a silly little commit message where I'm updating or, squashing bugs or initial check-in. I have a linkage back here. So then way down the line, when you start trying to move forward in your software process, here are all the things that I did for this project, tick, 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 tick. Everything's green, we're happy, all of our changes have been made, and we can kind of account for that. So then you unlock and life is good. So kind of a long-winded, drawn-out way of just saying you're going to have an extra form to fill out. But the reasoning behind it's kind of important because it's mainly used for like auditing purposes and traceability and things of that nature. And again, I keep using this term traceability. It's one that I quite like. It's making sure that like every requirement in your documents has related code to support it, which has test cases that are linked to it, which has maintenance activities that are linked to it. And if you ever see in this massive configuration management software that I'm kind of hand waving, actually literally hand waving here, if there's ever a requirement, for instance, that has no test cases or no code, you can go back and say, well, hey, why is this requirement here? We don't have anything for it. Or this code is never tested. That is a huge red flag for a project, right? So all of these little things along the way kind of build up into a big, big thing later on. So it's important to kind of keep up with this. Alrighty, so now we're going to talk about branching a bit. So here we have a very similar view. Again, lovely pixelated. Looks like an old typewriter made this, but this is what happens when you stretch out a figure. We have the same thing. So file, lock, get access, change file, check and unlock, right? Same path that we had before. This would be, say, your mainline branch, your base branch, or your master branch. And for nicety's sake, if you're not sure if you're aware or not, if you are a GitHub person, they're changing their naming from master to main. So that's kind of a good thing. But if you're ever notice in GitHub, that's why that change is happening. I just saw the news like earlier today, so thought that was kind of interesting. But anyway, here is our initial branch right here. Okay, so we have a file. Again, can lock and lock it, edit it, whatever you want to do. We can also make branches. So I have this file at a particular version, and I do something called branching. Now, if you did that little JavaScript gamey thing that would like that part 1 for GitHub, you did some initial branching and rebasing and merging and all of that fun stuff. Maybe you didn't know what that meant. Basically, what we're doing is we're taking this and we're working on a separate feature. All right, so now I have a file A, this is version Y. Here it was version X. So I've made some kind of a change where I have 2 instances of this file, but with different versions, and I'm going to keep working on each of them separately. Why would I want to do something like this? And you can even go further. I can have 1 branch, 2 branch, X branches. Why would you want to branch? Kind of mentioned features, so that might be a hint for you guys. You all, sorry. Anybody have any guesses on why we would want to branch? Add multiple elements without altering the master in case bugs occur. Pretty much exactly right. So we can have multiple reasons for branching. One would be to explore a new feature. All right, so let's say this main is our production branch. Okay, this is what we're pushing out for the customer to see. And you, the new developer, wants to add a new feature. But you have to make sure it works with the code base. You have to make sure that everything is okay. So you're going to work on your feature in a separate branch. And when you're happy with your feature, you merge it back into wherever the branch is currently. Another one, allow people to work separately. Sure, you could have multiple branches where people are working on separate things at the same time. They're all based on the same main branch. You all have your separate ones that you're working on, and when you're done, you merge them back in. So yeah, definitely 2 good things. Another one, take an example from my youth, I guess. When I was in automotive, we would have 1 branch for our main product development and separate branches for each particular module we would have. So we had like all of these pieces of hardware. They all had the same microcontroller. They all had the same, basic features. And if you wanted it to be a radar or a camera or a laser or a LiDAR or something like that, you would add different components. So the base code would all be the same. So let's say that our basic stuff like booting the system up or communicating on a network or, parsing out data, this is all the same. But if you need special features like, okay, let's use our camera to detect cars and pedestrians and traffic signs, that's a separate branch, right? Radar, same thing, separate branch for, handling radar signals or LiDAR signals or what have you. So you just have separate files, maybe different versions of of similar files for different features, things of that nature. So yeah, we that multiple reasons to branch basically. Usually it's a good idea to keep branches more minimal so that you don't have too crazy of a development tree, because that gets to be a big headache later on. Another thing, I guess the other thing I should mention too here, again, this is not just 1 file, this is a whole project. So I might have a project full of files and source code and all that, and we can branch a project too. All right, so the flip side, we can branch, we can also merge back down. So we have a file with two versions here, so we have two branches, right? So file A, version X, version Y. I'm going to make some changes on this branch, make some changes on our main branch, and then I'm done with this upper branch here. I want to merge my changes back in to the main line, right? So I'm happy with my feature, or everything is verified and I'm good to go, or we're done with this bug fixing process, whatever the reason for the branches, we're done. The step now is that you have to take all the changes that you made in here and merge them in. Any of you ever used a diff tool before? I'm pretty sure it's built into like Notepad++ or Sublime. Definitely built right into the Linux terminal. But they are basically tools that show you the differences in files. Like you get a nice side-by-side view of, okay, all of this code was added, this was deleted, and it allows you to like just copy and paste, kind of interlace the two files together so that you can very easily manage the changes. And what that will do is that you can say merge in all the changes from this file into here, and then you're done, right? You check this file out, or you make your changes from here to here, close this branch, life is good. You know, obviously it's not that easy. You have to go through and make sure that, hey, none of the changes that I made in here broke the development that's happened so far down here. So it can be a little bit of a headache to check, but it's not as bad as I'm making it out to be. It boils down to copying and pasting code from one file to another. Alrighty, so moving on. So we had merging and branching, and we had locking and unlocking. Now let's talk about tagging and baselining. This is where we're going to have a few different terms for the same thing. Again, depends on your system you're using. Tagging, baselining, releasing, just depends on your system. What you're really doing is creating a state or a snapshot of all of your files at a particular point in time. All right, so consider it an approved state or a milestone. All right, so I'm going to create a release candidate, or I'm going to create, you know, an internal version that's ready for the team to work on or something like that. And all that means is that whatever state my project is in, so all these different files, again, we don't care what they are, source code, artifacts, documents, whatever, they're going to have a version tagged with them, right? Or associated with them, right? So this could be like version 1.1, version 0.5, blah, 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 all the way down. And it's going to have all of that commit history with it. Who worked on what, which projects were they filed with, etc., etc. We're going to create a tag or a baseline, and that's going to have a name that we can associate with it. Internal release candidate 1, snapshot for GDC, or early alpha, you know, whatever you want to tag this thing as. This is an easy way for you to know what version, what state your system is at. And this can be used as a basis for change. And what that means is that I might need like a change request to update a release candidate for production, for instance, or I might need to take our demo and make it, you know, add some security measures to harden it later on. So this is basically just a fancy way of naming something for you as you go. And we have different types of baselines or tags that you can add to. So you might have, I've got a little cheat sheet here that I'm looking at just to make sure I cover everything. So you might have like an early baseline where all of your requirements are in place, or you might have a development baseline where you have a prototype, where you have some work products already in there. Or, you know, basically you can make as many different baselines as you want. And if you get to a point where you're happy with your baseline, you can move forward in your software design process, which is kind of nice. And this is basically just a filled in figure from what we saw here. Hey, everything okay? I'm teaching right now, honey. Can we do this in a few minutes? Okay. Anyway, it's Good, class is almost over. Seems like it's nap time. For me too, maybe. This is basically just a filled-in figure with version numbers, right? So again, these files could be anything, but we have a nice set of files that go into our various revision. Wholesome blooper. Yeah, that was a nice wholesome one. It's when they come in crying and screaming that somebody got hurt is the problem. All right, so this has all been development so far. All right, everything has been internal. We've been going through all of our internal processes. Let's talk about release configuration a little bit. There is a slight difference in this figure here. So before, we just created a baseline, created a tag, and that's where we're at. Let's move on to the next version internally, right? Let's toss in the customer or the client. And that's where we get into release configuration management. And again, keep in mind, customer can be internal. Customer can be your boss's boss or whoever you are giving the output of your work to. So we still have our files, still have our tags or baselines, still have whatever package we're wrapping up nicely. This will then go into some kind of a build process, and we're going to create an actual formal release. I've been tossing around like release candidate is the term. This is where you have a set, ready to be deployed release for somebody. Again, that could be internal or external. Now, with this build process, we'll come back to this in a moment. We'll have a nice name, a nice version number, and that's going to go into our little formal repository here. And if you've taken databases before, any kind of class where you've had to do a diagram, this is your basic diagram for or your basic figure for a database, right? Little cylinder. We might have proof of verification, and all that means is that we're showing our test cases are passing. We're showing that we have all of our coverage metrics for checking all of our source code, or that all of our models have been run correctly. So whatever process we're using to show that our software works, right? So that would be part and parcel of this. This build process, though, is interesting because there's a whole lot going on here that's not shown in the graph. So this is where it's either going to be a manual or an automated process. And some of you have probably heard of the automated side. This is your CI/CD type of thing, right? So your continuous integration or your continuous deployment. If you've ever looked at GitHub, for instance, looked at some open source projects where they have that nifty little like build passing tag. So I'm going to use this one because they have a nice build passing tag. So this is that game that I will sporadically play, but the little tag, build passing. You click it, and it takes you to this thing called Travis CI. Now, this is a automated continuous build engine, basically. So you set up all of your test cases, you set up all of your compilation steps. So this project is all C++, so they have to go through a big build process. Check all of your compiler flags. So are you building it for the web? Are you building it with your debug flags? Are you checking your white space? Are you building everything or just part of it? So basically there's a whole lot of different checks to make here, right? This particular build process is just making sure all of our tests are passed, and it's doing it in an automated fashion. And you can see here that the last test ran for almost an hour. The total time took 2.5 hours. And here we have a build ID that it passed. Your build can fail. You can have all kinds of problems. Point is, this is an automated step here. If we consider this from, a more traditional viewpoint, this build process would be manual. So you set up all your test cases, you set up all of your steps for creating a build for somebody. This could include things like code reviews, managerial reviews, customer interactions, basically everything that is going to ensure that your software is ready to go. Could be manual, could be automated, but there are a whole series of steps that go into creating a build, right? You don't want to build something, give it to person B, and then have it crash, right? See enough of that in the games industry. So we're going to pass through that. We'll get a release, and then we track it till the end of time. All right, so now that we're getting towards the end here, I have a link here at the bottom, which is kind of helpful if you're getting lost in some of these terms, because we have config management, we have change management, we have development versus release configuration management. So there's a bunch of different terms which all mean similar things. This is kind of helpful. I'm not going to necessarily sit here and ask you for this because I know you probably are aware of it by now since we've been talking about it for the past 46 minutes. But the development side, this is going to be your continuous process, right? This is your internal, let's have project checkpoints, project milestones. Let's build an internal release. Let's keep iterating our project. Again, we're following our formal procedures and getting through the various steps in our configuration management is basically akin to moving through some of our software design lifecycle processes. When you get to the release side of things, this is where you take some of the extra steps, the formalisms for proving that your software is ready to go, and then you create a fully featured release. All right, so we have that. All right, I think we're going to end here and we'll pick up with this on Wednesday. Does anybody have any questions at all from today? And the thing that I should again reiterate is that this is all the more standard way of handling revision control and config management, right? The new and exciting stuff like Git, we'll talk about more next time. In the spoilery look ahead is that this is all kind of server-centric in a way. GitHub is distributed, and that's kind of the key difference there. Not a question from today, but from the proposal template. What does method approach mean specifically? Agile, waterfall, etc. Yeah, so good question. All I'm looking for is what kind of a design software process, software design process is your team gonna try to follow. I'm not gonna hold you to it, but based on kind of the different types of development we talked about last week, I'm kind of curious what would work for your team. So I'm not going to ask you to do like daily stand-ups, or I'm not going to ask you to go through a milestone checkoff process. I'm more so seeing, would you guys follow an agile type of process where, you talk about the features for the day or the week and then you work on them? Or are you going to go a more, waterfall-y kind of approach where you spec everything out first and then you build it later on? Yeah, hopefully that's helpful. I guess that kind of a question while I'm waiting for the for your response to come in. I'm just trying to get you to kind of start thinking of how you're going to work well as a team, right? Because that's one of the trickier parts is um, functioning together, right? Rather than me just mashing you together, how can you all kind of work together well? And if you're all kind of on the same page with your development process, it goes a long way, honestly. Alrighty, well, I think that's about all I got for you today. Um, and today is the 21st. So you basically have a week and a day for your first real big homework assignment. So good luck with that. Again, let me know if you have questions, and as always, I'll be on the Discord to answer them, or email, or wherever you want to get a hold of me. Anyway, have a wonderful day, everybody, and I will see you all Wednesday. Bye bye.